Alright, we're going to have a little video here on systems of linear equations. Systems of equations. Now, a system is just several things that work together to do one job. So a system of equations might describe some type of situation where you've got multiple things going on, but yet those multiple things describe one situation. That was the worst example ever. However, we're going to talk about graphing just this, and we'll talk about contextual problems another time. So look, basically, if I have a solution, it's going to be an ordered pair. It's going to look like x comma y, and that will be a solution to both equations. It'll be a number x and a number y that makes both of these true. That's what the solution will look like. So what we're going to do here is we're actually going to solve this system of equations. These are two equations that work together. We're going to solve this system by graphing. Alright, so the first one right here. A lot of people, they find ordered pairs that work, like they say, oh look, 0, 0 works, and 4, negative 4 works. Those are values for x and y that you can plug in, and they'll both be true. 4, negative 4, right here. I prefer to graph it another way. I look at this and I see that the y-intercept is 0, and the slope is negative 1, down 1 over 1. As you can see, I miscounted right there. 4, negative 4 is right there. But as you can see, they line up the same. So what I'm talking about right here, I missed. I can't count. You can teach math. Those who can do, those who can't teach. Anyway, there's our line. Now, every little dot on this line will be a solution to that equation. That's what a graph represents. This is a picture of all the answers to that equation. That's why we graph. You could never write all the answers. There are infinitely many, but we can draw a picture and just look at it and learn a lot of information about this equation. Our second equation has a y-intercept of negative 3 and a slope of 1/2. So you're going to go up 1 and over 1, 2. Up 1 over 1, 2. That should be enough information to make our graph here. Always a good idea to label these equations again. Now, this blue line, it's a picture of all the answers to this equation. The red line is a picture of all the answers to that equation. So together, where they cross, that's the one place they have in common. That's the solution that they share. The coordinate right here, it's 2 comma negative 2. So that's going to be the solution to this equation, this system of equations. Now let's check. Sometimes you're just given a solution and asked to verify. All you got to do is you got to plug in x and y. So y equals negative x. So here y is negative 2 and x is 2. See, like this. That's a true statement. Those are equal. Now let's check the second equation. So that's the first one. The second one says y equals 1/2 x minus 3. So y is negative 2. X is positive 2. This is true also. See, half of 2 is 1. 2 does equal 1 minus 3. Negative 2 does equal 1 minus 3. So, it is a solution. So that's how you find a solution to a system of equations, by graphing. Now, sometimes they're written in standard form, or sometimes they're written in no form at all. It doesn't really matter. If you're having trouble graphing from standard form, then you just need to practice that a little bit. We'll make another video right now where we do that. But the big idea here is that in order to solve a system of equations by graphing, you graph both lines, and where they cross, that is your solution.